Hello friends, welcome to this online session of the new topic electrostatic potential due to multiple charges. So already we derived for a single charge, and in the single charge we find that the potential is inversely proportional to R. So V comes out to be equal to K Q upon R. So now if we have large number of charges distributed in some region, then how to find out potential due to all those charges? That is our today's topic. So we have large number of charges, or we have a system of charges, Q1, Q2 up to Qn, n number of charges, they are distributed in some region. So we have this situation of discrete distributions. Discrete, it's not a continuous distribution. So we will discuss the continuous distribution after this topic. So first of all, I would like to cover the discrete distribution of charges. Okay, so let me just brief you the topic we will cover today. So two topic we will cover. First is the discrete distribution of the charges. Discrete distribution of charges, and second is the continuous distribution of the charges. Continuous distribution of charges. So we will cover these two topics today. So first I will take the discrete distribution of charges. So let me take, we have these few charges distributed in this space, and this is Q1 at a distance R1 from point P, Q2 at a distance R2 from point P. This point P is the point where we are going to find the overall potential due to all these charges. So we will find the potential at point P due to Q1, due to Q2, due to Q3, and due to the nth charge. So we are given the position of Q1 from P, the position of Q2 from P, position of Q3 from P. So positions are given. So we know that in our earlier case, we discussed that each charge has a potential V at this point P. So that is given by V1. So let me just show you. So the potential is given as due to Q1, the potential will be V1, and due to Q2, the potential will be V2, and likewise the potential at Q3, it will be V3. So the overall potential at point P, that will be the algebraic sum of all these potentials. So very simply, we will find out the total potential at P, Vp, is equal to V1 plus V2 plus V3, or if we take the nth charge, then due to that we will get the Vn. So Vp is equal to, what is the potential due to this Q1 charge? So V1 can be written as K Q1 and R1 plus K Q2 upon R2 plus K Q3 upon R3 and plus K Qn upon Rn. So we can write Vp is equal to, we can take this K outside, so it is Q1 upon R1 plus Q2 upon R2 plus Qn upon Rn. So we can write this Vp is equal to K summation I is equal to 1 to I is equal to N and Qi Ri. So this is the net potential due to the n number of discrete charges distributed in some space at point P. But if we have another case in which the charges, they are not distributed discretely, they are distributed continually. So how to find out the potential? So here we are shown that there is a space from Q1 to Q2. But if there are still some new charges in between Q1 and Q2, around Q1, large number of charges, around Q2, large number of charges, Q3. So the whole space is occupied by the charges. So how to deal with that situation? So before that, again, let me just show all my writing content with the help of the PPT. So we know that potential is a scalar function. So if we want to find out the overall potential at any point P due to n number of charges, then we will find the potential of individual charge. So individual charge V1, V2, V3, and keep in mind that potential of a single charge remains unaffected by the presence of any nearby charge. So when we are calculating V1, so the nearby charge's potential means at that time V2 is not going to affect V1. Likewise, any potential during the calculation of potential due to any charge at that time, any other nearby charge that never contribute or never disturb that potential. So the overall potential is equal to 1 upon 4 pi epsilon naught Q1 upon R1 for V1, 1 upon 4 pi epsilon naught Q2 upon R2 for V2, 1 upon 4 pi epsilon naught Q3 upon R3. So like this we can find out. So this is potential due to discrete distribution of charges. So if the charges they are not discrete distributed, they are distributed continuously. So how to find the potential? So let me use the whiteboard of the Zoom. So let us find that. So charges, they are, suppose I take so continuous distribution of charges. So suppose we have some area, and over that area, large number of charges continually they are distributed on that area. So large number of charges, if they are distributed over the area A. So how to find out the potential at some point P due to all these charges? So this is a point P, and we are interested in finding VP at this point. So very easy VP that we can find out with the help of 1 over 4 pi epsilon naught and integration dq upon r. So what is this dq? This dq is very infinitely small charge element, very infinitely small charge element over the surface area A. So this is a differential element, differential element. So हमने एक बिल्कुल छोटा सा चार्ज लिया, मींस जितना छोटा चार्ज हम ले सकते थे वो स्मॉलेस्ट चार्ज हमने लिया, और उस स्मॉलेस्ट चार्ज को हम इंटीग्रेट करेंगे, एंड देन वी विल फाइंड द पोटेंशियल due to the whole distribution of charges. And we know that in case of surface charge distribution, the surface charge density is written as surface charge density which is represented by sigma. So sigma is equal to dq upon dA. So from here we can find out dq. So dq is equal to sigma into dA. And finally, we will place the value of dq over here. So we will find Vp potential at P due to large number of continuously spreaded charges over the area A. So this is sigma into dA over A. So in this way, we can find out the potential due to large number of charges distributed over an area. So likewise, we can find out the charges distributed over the volume. So charges distributed over the volume. So we can find out the volume charge density, and that can be written as rho is equal to dq upon dv. So now what will be the potential in this case at point P? So Vp is equal to 1 upon 4 pi epsilon naught. Now this is a volume, this is volume integral, this is surface integral. So this is surface integral, this is surface integral. You call this surface integral and call this volume integral. वॉल्यूम को हमने इंटीग्रेट किया और वैसे ही किया हमने यहाँ पे स्मॉल चार्ज लिया dq और dq upon r. So now we will place the value of dq. So we will get 1 upon 4 pi epsilon naught, and this is volume integral, and dq is replaced by rho into dv divided by r. So this is the method to find out continuous charge distribution. In discrete distribution, we use the summation sign, and in continuous charge distribution, we use the integral sign. We take the surface integral if we want to find out the continuously charged distributed at some area, and we are interested in finding the potential. Likewise, if the charge is distributed over the volume, then we will find the volume integral. So sometimes charges may be distributed, they are not all the time positive charges. If we have combination of positive and negative charges, so what to do in that situation? If combination of, so let me take one case of discrete distribution of charges, but positive and negative, both the charges, they are distributed. So how to find out the overall potential at some point P due to that discrete distribution? So that is also very easy. So the concept is that we know that the potential that depends upon the type of charge we are taking. So for positive charge, potential at a point P, that comes out to be positive, that is positive. But potential due to a negative charge, at a point P, that is negative. So it means the potential that depends upon the type of charge we are taking. So in this case, I have a discrete distribution of charges, of charges, both positive and negative. So find the potential at point P. So let me take, we have a charge plus Q1 here, and we have a charge plus Q2 over here minus, sorry, this is Q2 minus Q3 here minus Q4 here. So we have these discrete charges and we are interested in finding the potential at a point P. So we are interested in VP. So what is this VP? So what we will take the distance of Q1 from this point P. So let me take, this is R1 and this is for Q2, this is R2, and for Q3, this is R3, and for Q4, this is R4. So now what is VP? So VP is equal to K plus Q1 upon R1. So VP, that will be equal to, VP is equal to V1 plus V2 plus V3 plus V4. And this V1, V2, V3, V4, that depends upon the charge, polarity of the charge. So V1 is positive, so it is plus Q1 upon R1, plus V2 is also positive. So this is K Q2 upon R2, it is also positive. But V3 will be negative because we have a negative charge. So I will write minus K Q3 upon R3. And likewise, V4 is also negative. So I will write K Q4 upon R4. So VP can be written as K Q1 upon R1 plus Q2 upon R2 minus Q3 upon R3 minus Q4 upon R4. So VP is equal to K summation I is equal to 1 to I is equal to N, and I can write Qi upon Ri. Finally, even for the negative charges, I will use the same formula. So this is the method to find the overall potential due to large number of positive and negative charges discretely distributed. So let me take one numerical. So let us do one numerical, and the similar type of numerical we studied in electrostatic also, in electric field also. So what is the situation? We have a, so this is a simple numerical, and we have a system in which we have one plus Q charge over here, plus Q charge here, and other minus 3Q charge over here. So this is my x-axis, and this is x-axis. And question is that find out the point where the potential is 0. So find the point on x-axis, where potential is 0, where potential is 0. So potential 0 के लिए means कुछ ऐसी situation होगी, potential 0 तभी होगा जब हमारे पास suppose 2 charges हैं, एक के कारण potential V1 है और दूसरे के कारण V2 है. So अगर दोनों charges positive हैं तो potential 0 होने के कोई chances नहीं है. So ये वाली situation नहीं हो सकती V1 plus V2 is equal to 0 और V1 is equal to minus V2. So इस situation में तो नहीं हो सकता. So किस situation के अंदर this is not valid. So क्या होगा कि एक चार्ज, इसमें दोनों चार्जेस को हमने प्लस लिया, both the charges they are positive means plus Q है, और ये +3q है, तो इसमें तो पॉसिबल नहीं है कि पोटेंशियल 0 हो जाए। बट यहाँ पे हमारे पास एक प्लस चार्ज है, एक माइनस q चार्ज है, तो एक का पोटेंशियल, इसका पोटेंशियल प्लस होगा, प्लस v होगा, और इसका पोटेंशियल माइनस v होगा। सो इस केस के अंदर हम पोटेंशियल को 0 ले सकते हैं। सो लेट अस डू दैट। सो let me take a point, P, and the total distance between these two charges, let me take, this is A. So, and if this distance is taken x, then the remaining distance is A minus x. This is A minus x. So now I will find out the potential of this charge at point P. So potential of the first charge, so let me call that is V1. Let me call that is V1 due to plus Q charge, it is V1. So it will be equal to KQ upon X. Similarly, the potential due to the second, it is plus Q charge, and potential due to minus 3Q charge, that is equal to, that will be a negative potential, minus K3Q upon A minus X, Now the total potential V is equal to, that is V1 plus V2. So the total potential at that point, that should be equal to 0. So V is equal to 0. And what is the value of V1 KQ upon X minus K3Q upon A minus X? So we can write KQ upon X is equal to 3KQ upon A minus X. So K is cancelled, even the Q is cancelled. So what is left? It is 1 upon X is equal to 3 upon A minus X. So cross multiply this, we will get A minus X is equal to 3X. So we will get A is equal to 4X. This means X is equal to A by 4. So X is equal to A by 4. So now the value of X is A by 4. And now where this A by 4, that will be towards the smaller charge. ये जो A by 4 होगा, ये किधर होगा? A by 4 किधर चूज किया हमने? ये होगा जो सबसे छोटा चार्ज होगा, छोटे चार्ज की। कैसे? Because we know that V is equal to KQ upon R. So V is directly proportional to Q. जहाँ पे चार्ज ज्यादा होगा, वहां पे पोटेंशियल भी ज्यादा होगा, जहाँ पे चार्ज कम होगा वहां पे पोटेंशियल भी कम होगा। सो हमें फाइंड आउट करना है वेयर इज द पोटेंशियल 0, मींस कम पोटेंशियल किधर है। सो जिधर चार्ज कम होगा उधर पोटेंशियल भी कम होगा। सो चार्ज कम किधर है? सो चार्ज कम किधर है? ये चार्ज कम ये है, प्लस क्यू चार्ज, ये कम चार्ज है। सो जो जीरो पोटेंशियल का पॉइंट आएगा, मींस x इज इक्वल टू a by 4 आएगा, वो आएगा प्लस क्यू चार्ज की तरफ। ओके, so with this I will finish my today's session, and in the next session we will meet again. Thank you.